All right, so today we are going to be taking a look at our first day of probability. Please have your worksheet out in front of you so you can complete the notes as we go. When we talk about probability, we are always talking about having some sort of experiment. Now, in the case of probability, what that really means is you are performing an investigation in which you can have varying results. Okay, so for example, your experiment might be that you're going to flip a coin. Okay. And in the experiment, you are going to record what are called outcomes. So the outcomes are just a result from your experiment. So for example, if I'm flipping a coin, possible outcome could be heads. Your sample space is all possible outcomes. So for example, here our sample space for flipping a coin would be the set of heads and tails. All right, so for an example, if we're going to give the sample space and the number of outcomes, if we are selecting a state that begins with the letter O. So our options, we could have Ohio, Oklahoma, or Oregon. So there are 3 outcomes. All right, and then the next one you should know, so just a day of the week would be Monday through Friday, so there would be 7 possible outcomes if you want to fill that in. All right, so talking more specifically about probability, probability is the measure of chance of a specific outcome or event occurring. And that's going to be noted as P, meaning probability of E, kind of your event happening. It's always going to be expressed as a ratio of favorable outcomes to the total number of outcomes. And this ratio can be written as a fraction, a decimal, or a percent. And then remember that the largest probability that you can ever have, or the sum of all probabilities in a sample space, is always going to equal 1 or 100%. So let's look at an example. We're going to give each probability as a fraction, decimal, and percent based on this spinner. So the spinner below is used in a game. If it is spun once, we're going to find each probability. So when we look, we see the numbers 1 through 16. So the probability of getting a 9 would be, there's 1 9 on the wheel out of 16 possible outcomes. That as a fraction would be 0.0625. And then that as a percent would be 6.25%. Okay. Now what about the probability of at least 12? So if we think about the probability of at least 12, that would include 12, 13, 14, 15, and 16. So here we would have 5 out of 16 favorable outcomes, which becomes 0.3125 or 31.25%. So if you want to kind of finish those out, you can kind of look at the different probabilities for that. The next one I want to look at is just number 7, because some people don't have context for that, talking about cards in a deck. So in a standard deck of cards, there are 52 cards, 4 suits, okay? So here, the probability of a queen would become, since there's 4 suits, 4 out of, 52. So in that same procedure, 4 divided by 52 gives us 0.0769, and actually 4 out of 52 can be reduced to 1/18. Or a 7.69% chance of being selected. A red 3, there's 2 red suits out of 52, so there'd be 2 red 3s, which is going to be the same as 1 out of 26. Okay, and then you could finish that. And then a spade, there's 13 cards of each suit, so this would become 13 out of 52, which would also equal 1/4 of the deck is a spade. So that would be 0.25 or 25%. The main thing I want to focus on in this back page is what's called the complement of an event. So the complement of an event is the probability of the event not occurring. Sometimes this is helpful because it's easier to calculate the probability of it not occurring and then looking at it that way. Since the sum of all probabilities in a sample space is always 1, the probability of an event not occurring, or the probability of not E, would be 1 minus the probability of E. So all probabilities in an event should always add up to 1. So for example, if the probability that it will rain tomorrow is 3/8, what's the probability that it will not rain? Well, total probability would be 8 out of 8. There's a 3/8 chance probability that it will rain, leaving us with a 5/8 chance that it would not rain. And then just thinking about that as a decimal, right, would be 0.625 or 62.5%. Right? Number 9, if the probability that someone will win a game at the carnival is 1/24, what's the probability that they will not win? So there's 24 out of 24 chances. We're going to take away that 1 chance that they would win, leaving them with a 23 out of 24 chance that they will not win. Or in other words, this ends up being 0.95, and that's rounded, 958, or about a 96% chance that you would not win.